Assalamu alaikum everyone. My name is Nuzhath Khan.
Hello everyone, my name is Pashmia Walid.
So we will do our peer project together today. So let's start. First of all, I will share the screen. Pashmia, can you see my screen?
Yes, I can.
Okay, this is for lab 1B I will explain and lab 1C Pashmia will explain. Hmm, So the program I'm demonstrating the program I'm demonstrating is titled Add and Subtract version 2. The objective of this lab is to perform 32-bit arithmetic operation using the EAX register and to observe how register and memory value change during debugging in Visual Studio 2019 using the Irvine 32 library. So this is the code. This is our code. In my file lab 1b.asm, I first included Irvine 32 include so that I can use the dumrex procedure to display register values. In the data section, I declared value 1, value 2, and value 3 as D words, and final value to store the final result. In the code section under the main procedure, uh, I move value 1 I move value 1 into EAX, and in the second one add value 2, subtract value 3, stored the result in a final value. After finally call dumps to show the register content. This simple logic helps to visualize 32-bit addition and subtraction inside the procedure. So now we will see the debugging procedure. So after building, first of all we have to build and do start without debugging. So this is our output. Then I will close it and clean my solution, and I have to build solution and start debugging. So now I will just put a breakpoint in this line and run the code again. So you can see this one. After delete this, let's delete this one. Yeah, this is the breakpoint of our code. So I have to delete these things, and you can see. So then I start debugging by pressing F5. So the yellow arrow shows where the program is paused before execution. I have opened the I have opened the register watch 1, memory 1, and deassembly, disassembly, and windows so that I can observe changes step by step. So you can see if I put my variable name here, variable 1, it's taking the variable, variable 2, variable 3, and final variable. So this is our variable. If we search the variable in the memory section with, you can see this one, and we can see our code here. We need to restart it. So this line, move eax dot variable 1. This is the bytecode of our code. So now I'll step through the instruction using F10. After pressing F10, after move eax, after move eax, variable 1 eax equal 10,000h. After add eax, variable 2 eax equal 50,000h. After sub eax, variable 3 eax equal 30,000h. Then move final variable eax stores 30,000h in memory. When I call wrex, the console displays all register values confirming the expected result. The memory 1 window shows that the address of final value now contains 00093 00000H, and the disassembly window lists the corresponding machine byte codes. So after this, we can observe uh, how EAX, a 32-bit register, updates after every instruction using the watch, memory, and registers windows help me understand how data moves between register and memory in real time. Overall, this lab taught me how to trace 32-bit arithmetic instruction and verify them through dumb-rex. Thank you so much for watching lab 1B. So now Pashmia will present the lab 1C. Pashmia, can you present?
Yeah, sure.
First of all, I have to change this one. Yeah, you can start.
So, this is my Lab 1C presentation. The program title is Add and Subtract version 3. The aim is to perform arithmetic on both 16-bit and 8-bit unsigned integers and to observe how the X and H registers operate within the CPU during debugging. Now, for the code explanation, in my file lab1c.asm, I included Irvine32.inc. In the data section, I declared three word variables, variable w1, then there's w2 and w3, and there are uh, I use these variables to store the 16-bit result. 3-byte variables, variable b1, then b2 and b3. Then there's a final variable as well for the 8-bit result. In the code section, I first use the AX register for the 16-bit part, then use H for the 8-bit part. After each section, I call dump regs to show the updated register values. Now, moving on to the debugging process. At first, I need to build the project successfully. Press build, then rebuild it, then debug, start without debugging. Then this is the output that it shows. After that, we need to build again, then clean the solution. Then we have to go to build solution and then uh, start debugging. Now this is the output for it. So it set a breakpoint at the first executable line, moving AX and well W1. So after building the project successfully and setting a breakpoint at the first executable line, moving to AX and
So we have to add the variable here. Yes, we have to do a breakpoint here, the ninth one.
now like we can see we have opened register, watch, memory and disassembly windows and added all the variables into the watch window. Now stepping through with F10. After move AX to well W1, AX equal to 1000 hour. Then after adding AX to variable W2, AX equal to 5000 hour. Then after subtracting AX from variable W3, AX equal to 3000 hour. And the result is stored in final variable W and dump regs confirms AX equal to 3000 hour. Then the 8-bit part begins where the move age to well B1 age equal to 10 hour, then add age to B2 age equal to 50 hour, then subtracting age from the B3 age equal to 30 hour. This result is stored in final variable B and the second dump rex confirms the output. The This assembly window also displays the corresponding bytecodes for each instruction. Now moving on to the observations, like through this debugging, I observed how H and L and AX are parts of the 32-bit EAX register. Like it can any change in one affects the others. This lab helped us clearly understand how 8-bit and 16-bit data operations occur inside the processor, the watch, the memory, and registers windows along with dump regs. And it allowed me to trace the data flow accurately. In conclusion, Lab 1C demonstrates arithmetic operations at different data sizes and how to debug them effectively in MSM. Thank you. Thank you for watching our Lab 1 presentation.
Thank you.